Okay, so notes 5 is going to be over GCF and factor by grouping. So what's GCF? GCF stands for greatest common factor, so it's the largest number that you can take out of several terms. So all those numbers that they have in common. We're going to talk about how to factor out that GCF, how to factor out a negative factor, a binomial. A binomial just means two or more terms, and then factor by grouping. Okay, so this is kind of like our introduction before we get into factoring. So for these notes, we're focusing a lot on the quadratic equation for these next couple notes. Okay. So concept 1, identifying the GCF or greatest common factor. So GCF, or starting I guess with prime factorization, we can take all numbers and put them in terms of prime numbers. So what I mean by prime numbers is their numbers such as 2, 3, 5, 7, 11, etc. There is infinitely many prime numbers. And what prime numbers are numbers that are can only be divided by 1 in itself. So for example, 5 can only be divided by 1 and by 5. Okay, no other number. So that's why it's a prime number. Okay. And then again, GCF, we said it was the greatest common factor. So what we're going to do for each of these is we're going to do the prime factorization for every number, and then we're going to see what they have in common, and what they have in common is the GCF. Okay, so first example says find the GCF of 24 and 36. So for 24, okay, I'm going to do what is called a prime factor tree off of this. Okay, so that means I'm thinking to myself, what prime number can go into 24? And we always start with the lowest, so 2. So 2 goes into 24 how many times? 12. Okay, then I go off of 12. And I always stick with that same prime number until I can't use it anymore. So then I do 2 goes into 12 6 times, and then 2 goes into 6 3 times. I know I stop when I end with another prime number. So technically 24 is the same as saying 2 times 2 times 2 times 3. All of these prime numbers. Okay. And then I would do the same with 36. And what we're doing at the end of all this is seeing what prime numbers they have in common. So then I do 2 goes into 36 18 times. 2 goes into 18 9 times, and 2 can't go into 9, so I go on to my next prime number, which is 3. 3 goes into 9 3 times, which means 36 is the same as 2 times 2 times 3 times 3. Okay. And then I look at these and I say, okay, what numbers do they have in common?
2 and 3.
2 and 3, so they share a 2 like this, and they share a 3 like this. Anything else? Can they share another 3 or another 2? Another 2. Okay. So everything that they share, we multiply those numbers together. So 2 times 2 times 3 would give us our GCF of 12. That's our answer. Okay, so all the numbers they have in common, we multiply them together. 2 times 2 is 4. 4 times 3 is 12. Okay. These are kind of smaller numbers, right? So I bet you could have found that 12 is the GCF of 24 and 36 without doing these trees, okay? And that is by you taking the largest number you can think of that can divide into both, and that is 12. 12 can divide into 24, and 12 can divide into 36. Okay. This helps more when we have multiple numbers. So in this case, we have 3 numbers, or we have larger numbers. Okay, so we're going to do the same thing for this one, but now we're doing it on 105, 40, and 60. So for 105, okay, can I divide that by 2? No. Can I divide it by 3?
Yes.
What is it by 3?
35.
What is it again?
35.
35, okay. So 3 goes into 105 35 times. 3 goes into 35. Can 3 go into 35? No, right? So which one? 5 goes into 35 7 times. And then is 7 prime?
Yes.
Yes, so we stop. So that means 105 is 3 times 5 times 7. Okay, then we do 40. Okay, so 2 goes into 40 20 times. 2 goes into 20 10 times. 2 goes into 10 5 times. And then I look at all the prime numbers. So 40 is 2 times 2 times 2 times 5. And then I do the tree again on 60. So 2 goes into 60 30 times. 2 goes into 30 15 times. What can go into 15?
3 and 5.
3 and then 5. So good, we're ending with that prime number. So that means for 60, this is 2 times 2 times 3 times 5. So now that we did that for every single one, we need to look and see what they all three have in common. Okay? And good, 5. 5 would be the only number that they all have in common, which means the GCF would be 5. Okay? If there's only one number in common, then we don't need to multiply it by anything. That is just going to be the GCF.
You said you don't have to multiply it?
No, because there's only one number there. If there was more than one, then yeah, we would have to multiply them together. Okay, go ahead and take a moment and try 3. So you're finding the GCF between 12 and 20. And then while you guys are doing that, I'm just going to do the trees for both. So for this one, what's the GCF?
4.
4, good. They both have 2 2's that they could have in common. So we do 2 times 2, which is 4. So our GCF is 4. Okay, good. Go ahead and try number 4. And then same thing, while you guys are figuring out the GCF, I'm just going to put the trees up here so you can double check your work. Okay, so what would this GCF be? 15, good. So I wanted to show you here that, okay, now on this time, I didn't start with the smallest prime number, okay? But I still ended up getting the same answer. The most important thing here is that when you are using that prime factor tree, that you are only dividing by prime numbers, okay? That would be the most important. So for me, when I saw 45, I was like, okay, I know that's 5 times 9. And so that's the one I just wrote first. And then I know 9 is not prime, so I continue off of that. Okay, so yes, GCF is 15. Okay. Okay, now let's say we add in some variables. Okay, so we're going to treat the numbers the same. We're still going to look at 7, 14, and 21. But then now each of them have a number of x's with them. Okay. So let's first just look at the numbers. So between 7, 14, and 21, what is the biggest number that can divide into all three? 7, because 7's prime, and we can't really reduce 7 further. Good. So we know our GCF, the very first term is going to be 7. Okay, then we look at all the x's. And the first one has 3 x's by x cubed. The second one has 2 x's, x squared. And the last one has 4 x's, x to the 4th. So if I was going to take x's from all of them, what would be the most I can take out? 2 x's. So I'm going to write x squared. So that's my GCF, 7x squared. Okay, you always look at the numbers first and then look at the variables. Okay. And again, I can take out x squared because that's the most I can take out from all of them. Okay, I can't take more than x squared because the 14 caps out at x squared.
Is that it?
That's it. That's the answer. Yep.
Oh, okay. How does that work?
How is this the GCF?
No, I'm sorry. The x squared. How we found x squared.
X squared.
Yes, ma'am.
Okay, so I'm looking at all of these x's here. And you said, okay, these are 3 x's, right? There's 2 x's, there's 4 x's. We said that the most that we could take out of all of them was 2 x's. Okay, but we don't write 2 x's, right? We write x squared.
Of course.
Okay, so that's how we wrote, that's how we took out the x squared. Because that's the most we can take out of all 3, because 14 only has x squared. So you couldn't take out x to the 4th because this one only has 2 x's and this one only has 3. Okay, because you have to be able to see what can you take out from all 3.
Oh.
And that's ultimately what we're doing with the numbers, right? I said, what number can you take out of all 3? And you guys said 7.
Is the next one 5a cubed and just b?
Let's find out.
Oh.
Sounds like it. Yep. Okay. So on number 6 here, we're still starting with the numbers, okay? So looking at 15 and 25, what's the biggest number I can take out of both of them? 5. Okay, so GCF, the first answer, part of our answer is 5. Then I'm going to do the same thing, but notice there's more than one variable now. Well, I can only take out A's with A's and B's with B's. I can't interchange them. So this one has 4 A's and this one has 3 A's. So what's the most I can take out of both? 3 A's. And how would I write that? A cubed. Okay, then I look at B's. That one has 1 B and that one has 2 B's. What's the most B's that I can take out? 1. So I just write B. So this is my answer, 5a cubed B. Is that what you initially said?
Yes.
Okay, so this is important because when we get to factoring on the next notes, you're going to have to be able to take out the GCF fairly easily, okay? Because if you can't figure out how to take out the GCF, then the factoring part will be a challenge if you don't do that step first. That's why we're learning this little skill to build onto a bigger skill. Okay, go ahead and try 7. And remember, you can think to yourself, okay, out of all these three numbers, what's the biggest number I can take out? Or do the prime factor tree for all the three numbers, whatever is easiest for you. Okay, so what'd you guys get for this GCF?
5Z.
5Z, good. 5 is the most you can take out of 10, 15, and 40. And then we can only take out 1Z because 40 only has 1Z. Okay, so the answer is 5Z. Okay, okay, try 8. Okay, so what would be the GCF for this one?
3w cubed y squared.
W cubed y squared. Perfect. Yes. 3w cubed y squared. 3 because between 6 and 21, 3 is the biggest number we can take out from each. W cubed because that is the most we can take out of both. And then same with y squared. So 3w cubed y squared. Okay. Okay, so now let's look at this one together. This one, we're going to do the same thing. Let's start with the numbers. What can we take out of 8 and 6? 2, everyone agree?
Yes.
2? Okay, what about from the C's? How many can we take out?
Squared.
Good, the square, so C squared. Okay, what about D's? 4, good. What about E?
Just 1.
No, none.
None, right? Can we take it out if this term is missing one?
I thought maybe.
No, so they both have to have it in order for you to take it away. Okay, so if this said E as well, then we could take an E out. But since it doesn't have an E, that means our GCF cannot include that E.
Is this basically just simplifying?
Y- Yes.
So we can get to, like you said, finding certain variables, right?
For factoring, yep. Yep, so this is, yeah, the very beginning stages of
It's
factoring.
meant by the first step of the next following units.
Yes.
Factoring.
Okay.
That leads to factoring, right? It wasn't to factor.
Yes, always yes, factoring. Okay, now let's look at this one. Between 9 and 15. 3. Okay, the M's?
None.
None. Why can't I take out an M?
There's
There's
no
only
M.
one.
Yeah, the 15 doesn't have an M. I can't take it away. Okay, then I look at N's. How many N's?
Who knows?
1, yes. Okay, and then how many P's? 5, good. So my GCF is 3np to the 5th. Okay.
Is there a name for the 5? Kind of like 3 is cubed and 2 is squared.
No, it's just 5th. There's only after, yes, p to the 5th. After 3, they don't have fancy names anymore. It's just 4th, 5th, 6th, so on.
You have to refer them by their names, so, right? 3 cubes, you have to refer to it by cubes, right?
Yes, it's preferred, yeah. Or you could do like x to the 3rd power.
Right.
Okay, let's see. Okay, now we're going to get a little bit more challenging here. Okay, let's look at the numbers first. We have 3 and we have 2. Is there any number that we can take out of both? No, so we skip that one. Okay, there's no number we can take out of that. Okay, now let's look at x. Can we take out an x? Nope. Okay, what about y? Can we take out a y?
No.
Okay, now look at that entire part there. A plus b. This is an entire thing. A plus b. Okay, could we take out an a plus b?
Yes.
Yes. So if I take that out, my GCF is a plus b. And it's good to just leave it in those parentheses like they have it. Okay, so that means what they had in common that we could take out equally is just a plus b.
The 3 and the 2 have to be, is the word factored, right? But they're already like at the most, that's the prime number.
Oh, yes. They're already prime numbers, so we can't take out anything further. Technically,
So put them on, right?
correct. Technically, we are taking out a number, and what number is that? 1, right? Because the only number we could take out from both would be 1, but we don't need to write 1 in front of our a plus b. It doesn't make sense. So we just say we don't take out anything, so we don't need to write anything. Okay. What would I take out of here? What's the GCF?
X plus 2.
Perfect. X plus 2. Okay. Okay, so now that we learned what the GCF is, now we're going to learn how to factor out a GCF. So in order to do that, our first step would be to identify the GCF. So first, find what the GCF is. Okay. Then write each term as the product of a GCF and the other factor. You'll find out it's not as difficult as that sounds. And then use the distributive property to remove the GCF. So we're going to identify it, put it into 2 factors, and then take it out. Okay. So for example, we have 4x minus 20. What would be the GCF between the numbers? 4. So off to the side, I'm going to say my GCF is 4. But it's not asking for my GCF. It's asking for me to factor out the GCF. So instead here, I'm going to write 4. Okay. And then I'm going to write parentheses. Okay. And I'm going to look at each term, and I'm going to see what's left over if I take away a 4. So from 4x, if I take away that 4, what's left?
X minus 20.
X, okay? One term at a time, okay? And then if I do minus 20 and I take out a 4, so that's like negative 20 divided by 4, negative 5. So this is my answer here, this whole thing. 4 parentheses x minus 5. 4 was my GCF. I factored it out from 4x minus 20 and was left with x minus 5. Okay, now we're getting even closer to factoring. Okay.
So you just divide.
It's divide. Yep. Anytime I say, okay, how many can you take out? I'm thinking divide. Okay, because 4x divided by 4 is just x, and negative 20 divided by 4 is negative 5. Okay. So then for this one, what's the GCF? Oops. What's the GCF? Okay, 3 for the numbers. Anything for W's?
1.
Just one of the W's, right? So I can say that my GCF is 3W, which means I need to take that out. I need to divide each of these terms by 3W. So I write 3W, and then I do my parentheses. And then I do one bit at a time. 6 divided by 3 is 2. Okay. If I take one W away from 2 W's, I'm left with just the W. Okay. Bring down my plus sign. And then if I take 3 away from 3, it's going to be just 1. W away from W is going to be
None? Or is it like a
that.
dividing situation?
Yeah,
W?
so it'd be 1. So this would be a case where we would have to write the 1 because it wouldn't make sense if we just said 2w plus. Well, plus what? We have to write that 1 there. It's different when we were multiplying by it. It wasn't necessary to write.
You can't just drop it to W?
1 what? Exactly. It's not W though?
It's not a w because we had 3w here and we took away 3w. So that's why it's 1.
So because you divided it, it goes on the outside of the parentheses,
Correct.
and then what's left over is what's at the front of the parentheses, inside.
Correct.
Okay.
So it should always equal the top, basically.
Yes.
What's the secondary number again? It's 1, but like where's the 1 come from again?
The 1 is coming from us taking 3w out of 3w.
So it's basically the W that's left over.
Well, there's nothing left over. Because if you take 3 from 3, right, there's only 1.
Okay.
W from W, there's only 1. That's why we write the 1. Yes, and remember when we talked about in the beginning, okay, we could distribute. Okay, and distribute meant we multiplied in. Well, if you multiply this back in, you should end up with the original equation. And that's how you can check your work to see if you're doing it correctly. Okay?
So if you do 3w times 1,
Would be
3w.
3w. Mm-hmm.
That's true, okay.
Mm-hmm.
But now we're dividing inequalities and numbers together. We're able to do that.
Yes, variables and numbers.
Sorry.
Yes.
Variables, forgive me.
Mm-hmm.
Variables.
Mm-hmm. Yes. We're going to do that from here on out, from the rest of your math classes always.
Okay.
Okay, what's the GCF for this one? Well, there's a bigger one.
3.
There's a bigger one. 6. Right? GCF means greatest. So the biggest number that can divide into both. So then we take that 6, and in my parentheses, what's going to be left over? W, right? Okay, good. What else? Plus 3. And that's my answer. And if I was to distribute this back in, would I get my original equation?
Yes.
That's how I know I did it right.
Okay, that makes a lot more sense. So it would be like how is your W? But the W wasn't a part of our GCF.
Yes, yes. Okay, what about this GCF? 3. Anything about the y's?
3y, 3 squared.
3 cubed.
Good, 3y cubed. Okay, so then I'm going to take that over here, 3y cubed, do my parentheses, and I'm going to see what is left over. So I do it step by step. What's 15 divided by 3? 5. And then if I take y cubed from y cubed, is there any y's left? No, so I don't write any y's right there. So I just bring down the plus. Okay. Then I do 12 divided by 3, 4. And then y. Good, because I had 4 y's there. I'm taking away 3 of them. I'm only left with 1.
So with the numbers you divide, and with the variables you subtract.
Yeah, that's a good way to think about it. Yes. Mm-hmm.
So you go group by group. You don't have to necessarily go the entire.
I mean, you could think of it all at once,
Right, of course.
but it's easier just to look at every, like I look at every single part.
By the bottom GCF.
Yes, by this GCF here. Mm-hmm. Mm-hmm.
Okay.
Okay. Okay, go ahead and try this one. What GCF did you guys find for this one?
7.
Good, 7m. Okay, so I take that 7m, and then what do you guys have left in the parentheses?
3m squared minus 1.
Perfect, perfect. 3m squared minus 1. Okay, and how can you check if this is correct?
You multiply it.
Multiply it. What's the math word?
Distribute.
Distribute. Good, distribute. Okay, perfect. Okay, now we're adding in another term here. Okay, we're going to do the same exact thing. Okay, just make our parentheses a little bigger because we're going to have to fit more things in it this time. So, looking at this, let's first identify the GCF. So, 9, good, that would be for the numbers. What about the A's? A to the 4. And then, good, B, because they all have one B. So then I'm going to take that 9a to the 4b, do my parentheses, and I'm going to divide every single term. Notice that the very first term is our GCF. So I could divide that all together. I could say if they're the exact same and I need to divide by each other, then I would have what here? 1. Okay. Then I do the next part. Negative 18 divided by 9. Negative 2, right? Okay, a to the 5, take away a to the 4th. Just a. Okay, b, take away b. Is there any b's left? Nope. Then we move on to the next thing. Bring down that plus sign. 27 divided by 9. 3. How many A's do we have left over? 2. And do we have any B's? No. So that would be our answer. Okay. Okay. What about this one? What would be the GCF? 3. Good. What about Y's?
3y squared.
Y squared. Good. So if you did 3y squared, what would be left in your parentheses? 3. Good. Minus 2y cubed. Y cubed. Okay, and remember, these are all just skills adding up until we get to the very last part of this notes, and that's the main thing that you need to know. Okay, go ahead and try this one. Just remember, when you're doing GCF for the numbers, think of the biggest number that can go into all 3. Give you guys another 45 seconds or so. Okay, what'd you guys get for the GCF?
10 ST 5 ST.
Okay, good. I hear 10 and 5. 10 is going to be the correct one because 10 can go into all of them. So it's always the biggest one that can divide into each one. And then what'd you guys say for the variables?
5s squared minus 4t plus 1.
Okay, you're jumping ahead of me. Yeah, S and then T, right? The GCF was 10ST. You can only take out one S and you can only take out one t.
Question.
Yes.
I thought we were going by prime factors.
So if you did this by prime factors, then you would have got the prime factors 5 and 2 that they have in common, and then that would multiply to 10. Okay. So your GCF number, this number here, doesn't have to be prime. Okay? It doesn't have to be prime. It's whatever your prime numbers multiply up to. So if you were doing the trees for each of them.
Yeah, that's just like the long
Because
process.
GCF
Yes.
is an abbreviation for greatest common factor. Did you say that?
Sorry, say that again?
GCF abbreviation for greatest common
Greatest common factor, yes.
Greatest.
Yeah, and that's the most important part, the greatest, because there is something as the least common factor, right? So we have to make sure we're always doing the greatest common factor. Good, so if I was taking out 10st, then what am I left with inside the parentheses? 5s squared, good. Minus 4t, okay, good. Plus 1, perfect. Okay, perfect. Okay, and again, let's say you did it in the beginning where you had 5 as your greatest common factor. What you would notice is that numbers inside of here, you would be able to take out another GCF. Okay, but if we look at these, can I take a GCF out of these 3 terms? No, so it's another way I know, okay, I found the greatest one. Okay, now let's look at factoring out a negative factor. Okay. Oh no, it didn't copy the... Does it have it on your guys' paper, an equation there? No, okay, we'll skip those ones. Oh no, okay. Give me a minute, I'm gonna have to think of something because you need this. It didn't when I converted to PDF, didn't put the equations right here. It took off my equations. So let me see. Yeah, I have to find my original key. If not, we can always come back to it when I find those equations. Let's look at one more place. Linear inequalities. Nope, it's not there. Okay, we'll come back. We'll come back to this towards the end. I need time to find where those equations are. The main idea is, okay, they're giving you the GCF. They're saying the GCF is -3. Can you factor out that GCF? So it's what we're doing in these steps up here. Okay, they give you this part, and you have to write the parenthesis part. Okay.
Oh, from the equation.
From the equation, yes, but I need to find those equations for that to work.
Would you like to bring-
Yeah, it's supposed to be like these. I don't know why these copied down, but the other ones didn't. Okay, so next concept is factoring out a binomial factor. And we did this a little bit in the beginning when we factored out GCF, right? So looking at these two, what would be their GCF? What would they have in common? X plus 3. So I'm going to write x plus 3 on the outside. Okay, and it's going to be a little unique because it has its own parentheses, right? And then I'm going to do my parentheses again. So I took out x plus 3. This is a little different because if I take out x plus 3, I'm not really dividing anything out. I'm just saying, okay, if I removed x plus 3, what is left over? 2w minus 5. Because look, if I remove these, if I remove the x plus 3, because I said that's what they have in common, that's the GCF, I am left with 2w minus 5. And that's what I write in the parentheses next to it. Okay?
For instance, if you wanted to multiply, like, or is it considered multiplying
When we do which part?
when you want to check?
Oh, to check, yes. If you want to multiply or distribute, yes, then you would get the same thing. And so that would be this multiplying x plus 3 times 2w, which is this part right here.
So are you supposed to distribute? Oh, I understand. I understand why it's considered. Because I'm looking at the what is this called?
Oh, the parentheses.
Parentheses, yes.
Parentheses, yes.
Because I wouldn't distribute parentheses x plus 3 parentheses by 2w.
Oh, I see. Okay, you're thinking this.
Yes.
I mean, you could do that. I wouldn't do that in this concept just yet. Because the concept here is, can you take out something that they have in common? And that is the x plus 3. So if we were to distribute this in, we would no longer have an x plus 3 in common to take out. Okay, so this would be the answer. Okay. And it's all going to make sense when we put it all together. I think it's in the next concept. Okay, so for this one, what would you take out? A plus b, and what would be left over in the parentheses?
8y plus 9.
Plus 9, perfect. That's the answer. Okay. And going through the entire process, so starting with finding a GCF, getting all the way down to factoring out a binomial GCF, that entire process is called factor by grouping. So we're going to take all the concepts that we just talked about, and we're going to apply it to the major concept. This is the most important concept on here, right? If you want to practice anything for the test, it would be factor by grouping, okay? Because it's going to pull together all the concepts that we learned. So it says, in order to do factor by grouping, this is a special type of factor by grouping because here we're given 4 terms, okay? In the next notes, we'll learn how to do this from just 3 terms, but this is the EC level, right? So
So the less numbers you do,
sorry?
the less numbers you do, the harder it is?
The less, well, not necessarily. When we talk more about factoring trinomials, that is when we get more to quadratics. So technically, you won't see equations that look like this with the 4 terms. It will always be, at least in this course, like 3x squared plus 5x minus 10. And they're like, okay, you got to factor that. And it does get difficult with less terms because then we have to do extra steps in order to get to factor by grouping. So for factor by grouping, when you have 4 terms, your very first step, and it says it up there in the steps, I'm just going to break it down in this first example. Your first step is to take this and separate it 2 terms, 2 terms, and you do that by parentheses. So there's my first 2 terms, and here's my second 2 terms. And then notice in the second 2 terms, I took that plus sign with the 2bx, okay? Whatever sign that is, it's just going to follow that term. Okay. So that's my very first step. My second step is to take a GCF out of each one. Okay. So what GCF can I take out of my first parenthesis? 3a. Good. So 3a, what am I left over if I take out of 3a? X plus 4. Good. I did the second step. Take the GCF out of the first parentheses. Now I'm going to take the GCF out of the second parentheses. What would that be? 2b. What's left over if I take out a 2b? X plus 4. This is key. Notice how we both got x plus 4 when we took out our GCF. If you get the parentheses that are exactly the same like this, that means you did it right. Okay? If you ever get something where they're different, then you know you did something wrong. Okay? Next step is we take the GCF out of the binomial GCF out of this. Okay, and we said that they both have that x plus 4. So I'm going to take out an x plus 4. And then what's left over if I take out that x plus 4?
3a plus b2.
3a plus 2b. Good. And we knew it was plus 2b because it's a positive 2b. Okay, so this is my answer. Okay. So our first step is to put it in parentheses. The first two terms, the last two terms. The second step is to take the GCF from each. Okay. And then the last step is to take the binomial GCF out, and that was that x plus 4. So next one, what would I do first?
Root 5x plus 10y,
Mm.
and then ax plus 2y.
Perfect. Okay, next step.
Factor out 5.
Good. Take out a GCF of 5 from the first one, which means I'm left with,
X plus 2y.
X plus 2y.
perfect, x plus 2y. What's my next step? Good. Factor out the next GCF, which would be a. Good. And then I'm left with x plus 2y. Did I do this correct?
Yes.
How do you know?
Because they match.
Good, the parentheses match. And so now I factor out that binomial of x plus 2y, and what am I left over with? 5 plus a. That's my answer.
So that's going to be the most simplified answer.
For now.
For now.
For now, in this notes, yes. We'll also talk about the FOIL method, and that's the way to multiply out to get and check for the original. But I don't believe it's in this notes. I think it's in the next one. Okay, first step.
Separate them.
Like this?
No.
How?
Ax plus 2y.
Good.
Negative x and then y.
Good. We always include that sign. So in this case, that negative x. Okay, next step.
Find the greatest value.
Take out a GCF in the first one. Good. A. And we're left with
X.
xy or x
X plus
plus y, right? Okay. We know what's the goal. The goal is to also have a parentheses that has what?
X plus y.
X plus y. So what could we take out GCF-wise to make it become
-1.
a -1? So that's what got taken out for that one. Okay. So if I take out the binomial x plus y, I'm left with
A minus 1.
a minus 1. That's my answer. Okay. Okay, go ahead and try this one. Okay. Okay, so you guys should have grouped them and then took out a t and be left with u minus v. Okay, and then if we want u minus v, in this one, would you guys take out? A -1. So you're left with u minus v. So it's by taking out that -1, you change the sign of each of those variables. So then you have u minus v, and what was the last parenthesis here?
T minus 1.
T minus 1. That's your answer. Okay, so we're going to do the same thing again. We're going to put parentheses around the first two terms and then the last two terms. And then we're going to take out a GCF. So what would be the GCF of the first one?
4.
4. Is it more than 4? 8s, right? Because 8 can go into 16 and into 40, and I think that's the highest one that can go into both. So I would say 8, and then how many w's can we take out? 3, so w cubed. And then in the parenthesis, I'd be left with 2w minus 5. Okay, which means that's my goal. My goal is to get 2w minus 5 in the next one. So let's say you're not sure what the GCF is for the next one. Well, what would you have to take out from this first term, that -12w squared, to be left with 2w?
6.
So taking out a 6 would be left with -2w squared.
Negative.
-6? Any w's?
No. Yes.
Yes.
How many? 1. Good. So you take out a -6w. Okay. We also knew that because 1 is w, this is w squared and this is w, so we could take out a GCF of w. So when I take out a -6w, I'm left with 2w, and then 30 divided by -6, -5. And again, that's my parentheses match up. I know that I did it correctly. So then I have 2w minus 5, and what's going to be left over?
8w cubed
Minus 6w. Good. Okay. So ultimately, that very last step, what I'm doing is instead of writing 2w minus 5 2 times, I write it 1 time. So that's I'm taking out that binomial GCF. And then everything else left over on the outside becomes its own new parentheses. Okay? Okay, so we'll do the same thing on this one. I'm going to factor by grouping. Am I going to do my next parentheses here? No, I have to include what? The minus, that negative. Good. Okay, then I take out a GCF from the first one. What's the most I can take out of the first parenthesis?
3b squared.
What was the number?
3b squared.
3b squared. Good. 3b squared. Right, because we're taking out from 3 and 6, so the biggest number we could divide into both would be 3. Okay, and we can't take any a's because only the 3 has an a and the 6 doesn't. Okay, so then what are we left over if I take out 3b squared? A, good. plus 2. Okay, which means that's my goal, is to get a plus 2 in the next one. So looking at the next parentheses, what would be my GCF? Negative 12b. Okay, negative 12b, which means I'm left with a, and then negative 24 divided by negative 12 is positive 2, and then I'm matched up with a plus 2 in my parentheses.
Is it easier to, once you figure out, what's in your,
These parentheses?
once you figure out the first parentheses, like the a plus 2,
Mm-hmm.
just to plug it in into the next one and then find your GCF.
Yes, you could do that. That would be a good way to do that, because you know that they have to match.
They have to match.
The only thing is let's say you messed up on this one.
Okay.
Then you are going to end up carrying that mistake over. So I would use it more as like a check. Okay, I know that I need a plus 2. Let me see if that's even possible, to make sure that all the math lines up. And then also going back and saying, okay, is that really the GCF of that parentheses? Okay. Okay, and then my answer would be what?
A plus 2,
Mm-hmm.
and then AB squared minus 12B.
Good. 3b squared minus 12b. Perfect. That entire thing is my answer. Okay. And that is the end of the notes.